Hi folks, welcome to part 2 of the Chapter 4 Key Concepts Review for Math 521B, which is Pre-Calculus 11. We're looking at quadratic equations. In the last video we looked at factoring and graphical solutions. Here we're looking at square root principle, quadratic formula, the discriminant, and completing the square. There are a few disclaimers on the screen, and there's also a link to the downloadable notes in the video description below. Okay, let's get going. Square root principle. Here's what it says. There are two solutions to x squared equals 4. You could take 2 and square it, and that gives you 4. Or you could take negative 2 and square it, and that gives you 4. So x here could be 2 or negative 2. Similarly, x squared equals 3 has two solutions. Either x could be root 3, or x could be negative root 3. The square root principle says, if in the process of solving an equation we square root both sides, then we need to consider both the positive and negative possibilities, plus or minus. And we have a symbol for that, just plus or minus. So in this first one, we've got x squared equals 18. To get x on its own, I might decide to square root both sides. And when I do that, I need to invoke this plus or minus symbol. X could be either positive or negative square root of 18. Let's brush up on some of our grade 10 simplifying radical stuff. So square root of 18 could be broken up into root 9 and root 2, or plus or minus 3 root 2. And that means the two solutions are x equals 3 root 2 and x equals negative 3 root 2. If you tried either of those in your calculator and squared them, they would indeed give you 18. The second one, we have b, x minus 2 squared equals 25. So here, the first thing we're going to do is square root both sides. And when we do that, well, it'll get rid of the squared on the left, and we need a plus or minus on the right. Now, the square root of 25 we know is 5. And what that gives us is two solutions. One that looks like this, x minus 2 equals 5, and one that could be x minus 2 equals negative 5. In other words, the solutions are x equals 7 and x equals negative 3. You could throw them either one back in, so let's put in negative 3. If I put negative 3 back in and squared it, would that give me 25? Well, it would be negative 5 all squared equals 25. Yep, that gives us 25. So this must be a good solution. And we could do that with all the solutions. And since you have time on your secondary math assessment, I would suggest double checking all of your equations that way. Sub them in the original, see if it balances. Getting to the form in B is the job of completing the square, but we'll talk about that later. The main feature of completing the square is that it allows us to get the quadratic formula. So we're not doing a proof here of where this comes from. We might at the end of the video, but the main thing is that you know how to use it. So the solutions, or roots, to a quadratic equation of the form ax squared plus bx plus c equals 0, has to be in equals 0 form, is negative b plus or minus the square root of b squared minus 4ac all over 2a. That tells us something. The two most efficient ways to solve a quadratic are factoring if you can, and we did that in the last video, or quadratic formula. We had some other techniques like graphical solutions. We'll also look at completing the square. But if they don't tell you which way to solve it, you should do probably one of these two things. Try and factor it. If after 30 seconds factoring doesn't work, head to the quadratic formula. So here we're going to solve some basic ones using quadratic formula, just to get the hang of it. So first step is make one side 0, same as it was for factoring. In this, your coefficient of x squared is 1. Your coefficient of x is 5. And your constant term is negative 6. Let's throw that into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, what's that going to give us? 25 plus 24 under here, all over 2. Or square root of 49. Square root of 49 works out to be 7. So we're getting two solutions here. Either x is negative 5 plus 7 over 2, or it's negative 5 minus 7 over 2. This one would be 2 over 2, or 1. This one would be negative 12 over 2, or negative 6. So our solutions here are x equals 1, x equals negative 6. Now, I don't think for this one that was a particularly efficient method, but it works. Okay, what we would have preferred to do is just factor this. Say, look for numbers that add to 5, multiply to negative 6, factor it, elementary equations. But the answers had better be consistent. They work both ways. We get negative 6 and 1. Let's try another one. Here, you could factor it, but we'll practice using the quadratic formula. So in this case, we'd have an a value of 3. A is 3. B here is negative 2. And C is negative 5. Subbing into the quadratic formula, we'd have negative 2, which would be positive 2. There's our negative b. B squared minus 4 by a by c. Let's see what this gives us. All over 2 times a. So that's 2 plus or minus the square root of 4. This is going to be 12 times 5, so 60, all over 6. Or 2 plus or minus root 64 over 6. Follow it a little further. Root 64 we know is 8, so 2 plus or minus 8 all over 6 gives us two potential solutions, or two solutions. We could have 2 plus 8 over 6, which would be 10 over 6, or 5/3. Or we could have x equals 2 minus 8 over 6, which is negative 6 over 6, or negative 1. There are our two solutions. We could have got them by factoring as well, but it works fine like this. And it's really not that bad. You're just plugging in numbers. If you want to, you can use your calculator to help you out, and we might on the next couple. So here we've got one that wouldn't be factorable. We'd have an a value of 1, we'd have a b of negative 5, and a c of negative 1. Let's put all that stuff in. So x equals negative b, so negative negative 5 would be positive 5. Plus or minus the square root of negative 5 squared minus 4 times a times c. I guess we won't really need our calculator here. All over 2 times a. So that's 5 plus or minus 25, square root of 25, plus 4, all over 2. 5 plus or minus root 29 over 2. Root 29 doesn't simplify. 29 is prime. So we have two solutions here. We have this number, which is irrational, but that's okay. And we have this number, which is irrational, but is still a solution. So you can see how the quadratic formula kind of opens up the door to solutions. When we did factored form, the best you could find were either integer or rational solutions, ones that could be written as fractions. Here we can find some irrational solutions, ones that involve roots. Okay, one last one. In this one, a is 1, b is 1, c is 5. Let's set it up. We're pretty good at this point. So negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So that's 1 minus 20 up here, where x is negative 1 plus or minus the square root of negative 19 all over 2. Square root of negative 19. I've never seen that before. Let's check out what that is, if my calculator will come up. There we go. So square root of negative 19. Ooh, it is not happy. Non-real answer. That's right, you can't take the square root of a negative number. So this right here is trouble. It doesn't exist. We would say no solution, or no real solution, no real roots. And that's going to happen anytime whatever's underneath your square root symbol is negative. So that leads us to the discriminant. We've got an illegal operation alert. There are a few things in math we're not allowed to do. We're not allowed to divide by 0. We're not allowed to take even roots of negatives. So since we can't take the square root of a negative, the expression b squared minus 4ac determines the number of solutions for a quadratic equation. Remember, the quadratic formula is this. So whatever's under the square root sign, if it's negative, there's going to be no solution. The expression b squared minus 4ac is called the discriminant, and it's written with this little triangle, this delta triangle. And it discriminates how many solutions you have. If the discriminant's positive, then you're going to have 2 different solutions. If the discriminant's 0, there's 1 solution, or sometimes those are called 2 identical or repeating solutions. And if the discriminant's negative, there's no solution at all. And since the discriminant is this expression, we could rewrite the quadratic formula like this. Okay, let's put that to use, because you might want to find out whether there's actually an answer to an equation before you go and spend a lot of time solving it. So determine the number of roots. That's just looking at the discriminant. So in this case, the discriminant would be b squared, so that's 3 squared, minus 4 times a times c. Doesn't really matter what the value of this is, just what its sign is. So that's going to give us discriminant of 89. It's positive, therefore 2 distinct solutions, or 2 different solutions. Checking out the next one, well, discriminant here is going to be b squared minus 4ac. That's 144 minus 16 times 9, 144. Oh my, the discriminant is 0, so that means there is 1 solution. Or you could think of it as 2 identical solutions. On the graph, it would just look like 1 point of intersection, though. Okay, and finally, taking a look at this, you can probably guess what's going to happen here. Now, I need to bring that 7x over, and I'll show you one thing that I often see as a problem. People will do this and say, oh, a is 3, b is 5, c is negative 7. Bad. The order that you write them in matters. It's not just because you wrote the 5 second that it becomes the b. The c is going to be your constant term. The b is your coefficient of x. And a is your coefficient of x squared. So we should write it in descending powers of x, and that way we won't mess it up. A is 3, b is negative 7, c is 5. Discriminant is b squared minus 4 by A by C. Or 49 minus 60. Discriminant is negative 11. No real roots, no real solutions. Let's do a word problem that involves quadratics. So Jared's designing a logo that involves a right triangle with an area of 100 square centimeters. And one leg is 3 centimeters longer than the other. Find the length of the longer leg to the nearest tenth of a centimeter. Let's draw a picture to begin with. This is going to be a logo that looks like this. One leg is 3 centimeters longer than the other. So we could say, all right, this leg here of the right triangle is x. The other one is going to be x plus 3. So let x equal length of shorter leg, and then x plus 3 is length of longer leg. The area of a triangle is half base times height. So let's sub in what we know. We know that the area is 100. We know that the base is x, and we know that the height is x plus 3. Or in other words, we have a half x squared plus 3x. Now, I don't know about you, but I am not a big fan of fractions in these equations. So you can get rid of them. We can just multiply both sides by 2. You don't have to, but it's probably going to make our life a little bit easier. So the half will be gone. And we're left with x squared plus 3x. I know I need to make one side 0. I might take 30 seconds and try and factor this, because if it does factor, that would be convenient. But alas, it doesn't. So we're off to the quadratic formula. And I'll just write it over here. Okay, so we'll sub in x equals negative 3 plus or minus the square root of 3 squared minus 4 by 1 by negative 200. Okay. All over 2 times 1. Negative 3 plus or minus 9 plus 800 all over 2. Or in exact terms, the solutions are negative 3 plus or minus root 809 over 2. Now here we're asked for a decimal approximation to the nearest tenth, which means 1 decimal place. So let's try each of these in the calculator. If I put this in, I'm going to need to do it separately. So I'll go negative 3 minus the square root of 809. And then I'm going to press equals to make sure that the whole thing gets divided by 2. So x could be negative 15.7 in theory. Okay, I'll try the other one with the plus. Negative 3 plus the square root of 809 is 25.44. Divide that by 2. That's the other possibility, 12.72. So roughly 12.7. Okay, those are the decimal versions of that exact solution. Now let's take a look at the question. Have you ever met a triangle with a side length of negative 15? Probably not. This doesn't make sense in the context of the question. So now we found x is 12.7. Let's go back and see what x was. X was the shorter leg. The shorter leg is 12.7 centimeters. It asked us, though, for the longer leg. So the longer leg's just 3 centimeters bigger. The longer leg is 15.7 centimeters. Make sure you answer the question that is asked. I think that gets us through all our basic solving techniques for quadratics. You might end up with area problems that are a little more involved. I'm going to keep going here with completing the square. But unless you're specifically asked for completing the square, I'd be inclined not to do it as a technique for solving a single variable equation. For me, it would be factor. If factoring fails, off to the quadratic formula. Okay, but completing the square does show up specifically in the curriculum, so it is fair game for somebody to ask you to solve by completing the square. Let's take a look at this example to get the idea of the technique. Different teachers will do this in different orders, so if this looks subtly different, that's okay. It's still the same basic idea. So what we're going to start by doing is isolate the first two terms, the a and b. So that's going to give us 2x squared plus 3x equals 7. And now we're going to divide both sides by a. In this case, that would be 2. So if I divide this whole side by 2 and this whole side by 2, here's what I'm left with. X squared plus 3 over 2x equals 7 over 2. Now if you remember from completing the square, to get to vertex form, there was kind of a magic number we had to find. We're going to add it to both sides rather than add and subtract it from one side. So add half the coefficient of x squared to both sides. Okay, so that number is going to look like half of 3 over 2 would be 3 over 4 squared. And I'm going to add it here and add it here to keep the equation balanced. That gives me x squared plus 3 over 2x plus 9 over 16 equals 7 over 2 plus 9 over 16. Everything's still balanced. Factor left side as a perfect square trinomial. And we'll clean up the right side. Okay. So that perfect square trinomial on the left is going to turn into x plus 3/4 all squared, just half the middle. And we looked at that in the last chapter. Cleaning up the right side, well, I'd need a common factor or a common denominator here. So I'd have to times 7 over 2 by 8 over 8. That's going to give me 56 over 16 plus 9 over 16. And we'll just clean that up a little more. X plus 3/4 all squared gives me 65 over 16. Now we square root both sides. And don't forget the plus or minus, which was the first thing we did in this video, square root principle. So that's going to give us x plus 3/4 equals plus or minus the square root of 65 over 16. The square root of 16 is just 4. So we'll have plus or minus root 65 over 4. And now we can isolate x. Move that 3/4 over. And we get x equals negative 3/4 plus or minus root 65 over 4. Now, if you're looking for more resources on completing the square, there are a whole bunch of videos out there. I think that this is going to be easier on a question like this to plug into the quadratic formula. Okay, you can see all the steps. None of them are difficult, but they're easy to forget. And we could have just as easily written this as negative 3 plus or minus root 65 over 4, how it will look in the quadratic formula. Okay, so that's two different solutions. It's negative 3/4 plus root 65 over 4 and negative 3/4 minus root 65 over 4. Either of those forms give us both of those solutions. And I said the real value of completing the square was to get the quadratic formula. So this is for fun. This is unlikely to come up on your actual exam. But if we wanted to solve this by completing the square, let's go through the exact same steps. So isolate. And if you've had enough, feel free to turn off at this point. Isolate the first two terms. Okay, great. Divide by whatever a is. So that's going to give us x squared plus b over a x equals negative c over a. Now we have to add on that special number, and that is half the middle. So instead of b over a, it'll be b over 2a squared. I have to add it here and over here. So I'll have x squared plus b over a x plus b squared all over 4a squared equals, on this side I'm going to put that part first, the b squared over 4a squared minus c over a. I just happened to put it first. Now we're going to factor the left-hand side. So it factors to x plus half the middle coefficient. So that would be b over 2a, all squared. On the right-hand side, we're going to need a common denominator. So that means multiplying this by 4a so that we can put these things together. b squared over 4a squared minus, well, that'll be 4ac all over 4a squared. Or put those together. We have x plus b over 2a all squared is b squared minus 4ac all over 4a squared. Okay, we just followed the technique for completing the square, but we're using letters instead of specific numbers. And there's a real selling feature to that. When we actually do this, we should end up with something we can plug any values into. We're going to square root both sides. Don't forget your plus or minus. So I'll have x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared. I can move that b over 2a to the other side. So I'll have negative b over 2a plus or minus square root of b squared minus 4ac over the square root of 4a squared, because the square root of the whole thing is just square root of the top over square root of the bottom. Well, let's see what that gives us. Plus or minus b squared minus 4ac. Square root of 4a squared would just be 2a. Ooh, we've already got a common denominator. So let's put it all together over a common denominator. And what do you get? You get the quadratic formula. Now, this is not the only proof of the quadratic formula, and there are other ways that we could set it up that might have made it look a little bit easier. But this way it looks like exactly what we did over here. So that's where the quadratic formula comes from. But now that you have it, you might as well use it. Okay? So I would not be inclined to do completing the square unless you have to for a single variable equation. I hope that you found this helpful, and I'll see you on the next one. Take care. Bye-bye.